Thanks, Adam. So to begin with, can jump right into the phase one of work that we went through. So here are the results after phase one. Before I explain a little bit about what we did and how well we did, can define a metric that's not super common in the data science world. Well, accuracy certainly is, but the terminology that we're going to be using it in is more of a supply chain terminology. It's similar intuitions of MAPE, if you're familiar with that. Essentially can be thought of as the mean absolute deviation normalized relative to the total actuals and weighted by the cost of those particular items in our case, to get a measure of how the absolute errors dollar weighted compares to the actual sales. With that in mind, here we can see an example of our forecast during our holdout period. We can see for this particular retail client, as often a lot of clients do, they have major spikes in the holiday season, which was one of the sort of interesting challenges that we had to tackle for our throughout this engagement. The end results that we saw were quite substantial. We used a baseline of 52-week average because it was performing quite well, as surprisingly they do. And we leveraged that effectively in our model by predicting the difference between that 52-week average and our specific upcoming targets that we're trying to predict. This resulted in a 25% relative improvement in accuracy versus that 52-week average baseline, which we were comparing against. And the end use case of this is a demand forecast that is going to predict the sales for the upcoming 8 weeks. And then that will be directly received by the buyers at this client to help inform them what stock they want to be purchasing for the upcoming demand that they're going to be having for the next 8 weeks. That'll supply their distribution center, and then from there, they can allocate it to their different stores. This project has been through a few phases, like I mentioned before. In the beginning, we started with an initial model to get us off the ground. That one leveraged primarily features around promotional prices, as well as some seasonality. The big driver that we saw was, the biggest driver was certainly the promotional prices that allowed us to compete against and improve upon the 52-week average. There were a few other streams that we went down that weren't able to achieve the same successes, leveraging Facebook's profit, for those who are familiar, as well as trying to build out some models for specific groups of items, as opposed to one model that would be used across all items, essentially with some selection that I'll get into a little bit later on, how we decide between in production, whether we go with the AI forecast or whether we go with our baseline, the 52-week average, or a variant thereof. And in phase two, some of the enhancements that we had were around bringing in store inputs directly rather than aggregating them before passing them into our model, as well as coming up with some more complex ways to allow the model to understand what the difference is going to be in this holiday season and be able to leverage features effectively to hit those peaks. With that in mind, can talk a little bit more about how that went. So again, this ties into the phase two of work that we have done for this client. We can see that the AI model 2.0 does a much better job hitting those holiday peaks than the AI model initially. And we did that by using similar intuitions actually behind interactions in linear regression with the time period. We can see, we can see that we're able to forecast more effectively in that holiday period. We can also, one of the common things that we go through is we take a look at areas where we're performing well and areas we're not performing well. We saw for within our top 5 subdepartments, we track generally quite well, energy drinks being one of the ones where we did additionally well with quite a high accuracy there. And then there's some other areas after phase 2 where we were still aware that we had some room to improve. These weren't a major concern when we were going into production, as like I mentioned, we made a decision based on the performance in the holdout set, whether an item would be getting the 52-week average or the AI forecast. And so when odd things were happening, we were able to effectively allocate that 52-week average, but still something we wanted to try to remediate. And a lot of these were happening from the way that we developed our features. There was some room for enhancement in that, and I'll get into some more details about how exactly we did that. But essentially, when you're building out a feature, you want to be careful about how much data how much data that feature is leveraging, as well as if there were, very big outliers as inputs into that feature previously. So now can move on to phase 3, which was one of the big pushes was trying to enhance the model's robustness. Here is how we measured the different way of showing the model performance versus above, but gives more of a global picture and takes into account not just the performance of the AI forecast, but also the performance of the baseline. So taking a look at how we're performing globally and then measuring based on that. So we can see the impact of those enhancements in robustness, how that's affecting the coverage, and then how that's affecting the global accuracy. By coverage, I mean the percentage of sales that will be receiving the AI forecast. So this is where things were starting at in the beginning of phase 3. And here are some of the examples of the benefits of the enhancements in pre-processing. Often a lot of the big enhancements that you'll make when doing data science in industry is in the pre-processing and the feature engineering. The modeling certainly can, especially in certain areas, provide a nice bump as well. But often, especially when you're dealing with tabular data and time series data, you're going to get a larger bump by focusing in on your pre-processing and feature engineering areas. And that's what we saw here. Like I mentioned before, some of the features were susceptible to outliers in the past, as well as small data counts that would be inputs into those features. So we've tailored our pre-processing to do more nulling out of features when there wasn't enough data, as well as smooth out features that are dealing with ratios. When you have ratios, you have to be careful about ratios with very low quantities, as the ratios can be exaggerated to a much larger degree. So those were the areas that we focused in to be able to see a nice enhancement in here, as well as some of the work that we did to improve our ability to hit those holiday peaks also helped us out, bringing these items back into the fold. Whereas beforehand, these were some of our most problematic subdepartments, and we were able to see a very large reduction in the dollar-weighted errors after phase 3. Speaking of the holiday peaks that we were focusing in on, so for this one, we built out some more tailored features that we referred to as amplifiers, essentially trying to really lift up the forecast in those particular holiday seasons. And we see that we're able to bring up the forecast even further beyond phase 2 within that holiday range. I mentioned before about how we decide between the 52-week average and the AI forecast. Before phase 3, this was done in a more manual process where we would inspect the residuals, get an understanding of how the model is performing on different items. But the client has a very large number of items, so this would have to be done on aggregate. And they also switch items in and out. So there was a lot of incentive to be able to do this automatically. And that's what we built out here, was a process of dynamic model selection that will take into account things that you would want to be checking for when you are trying to decide whether a particular item should be getting an AI forecast in production or not, but doing it in a more automated fashion, such as looking for very large over predictions and things like that. Another area of focus for phase 3 was COVID-19, which was obviously a big thing, around the world, and obviously. It also affects our models quite a bit. Our models in production, especially time series models, those we're very worried about how those were going to be, or in particular, how this model was going to be affected by that. We were able to perform an investigation where we simulated the COVID-19 echo by placing the COVID-19 phenomenon earlier, and then evaluating the AI forecast if we sort of put things back to normal the year after that. So that allowed us to get an idea of whether the COVID-19 big spikes in March, which you can see here, for example, whether that's really going to hurt us the next year. And we were able to see that it wasn't as large of an impact as we expected. Our model was still able to be able to do quite a solid job, especially with some of the new feature enhancements that we made to be more resistant to large spikes like that aren't in, especially not in the holiday season. And another enhancement that we made that helped us with our global performance as well as with COVID-19 is not for the direct training of the model, but for the production decision to go between the AI forecast or a baseline. We switched that baseline out, instead of going with a 52-week average, going with a mean median model, essentially where we're using the median in the non-holiday season and then the average or the mean in the holiday season. This makes it much more resistant to large outliers, such as the COVID-19 spike in March. And yeah, that resulted, all of those enhancements gave us a nice improvement in the global accuracy of 3.92%. And yeah, also some enhanced robustness in regards to the COVID-19 handling, as well as the enhancements in the pre-processing. And that's yeah, that's everything.